Good evening. I am John Orsini with BSHM Architects. Tonight, we will be discussing the sustainable approach to Quaker Valley High School. This study includes elements of the design that will aid in the savings of energies for your new building. Our team for this project included BSHM Architects, Bolin Sawinski Jackson, and Karpinski Engineering.
Thanks, John. Hi, everyone. This is Patricia Cully with Bolin Sawinski Jackson. Using a holistic approach to sustainable design, the new Quaker Valley High School project currently includes a variety of sustainable design features. Sustainable design is a broad term encompassing criteria for water, energy, material and resources, and much more. The current holistic sustainable design approach for the high school includes respect for the natural landscape and ecologically sensitive areas, optimization of water and energy use with careful selection of plumbing fixtures and lighting, considerations for regionally sourced materials and reuse of existing materials, care for indoor environmental quality by providing natural day lighting and views for instructional spaces, low VOC materials, and acoustic design, and many other sustainable design features. In addition to this holistic sustainable design approach, the school district expressed a desire for focused investigations into energy reduction strategies, which provide the most direct and highest value proposition for the district. As such, the school board approved a study by the project team to assess the ability to achieve a net zero energy ready project. Net zero energy ready projects are designed and constructed to be highly efficient, such that future on-site or local renewable energy sources can offset the school's total annual energy consumption. While there are different pathways for achieving net zero energy ready, the basic concept is that the amount of energy generated on the site exceeds the amount consumed by the building over the course of a year. The first step towards this goal is to reduce the energy consumption of the building as much as possible. Then the next step is to size a renewable energy system to produce the same amount of energy as an offset. To understand the viability of achieving a net zero energy ready project, the design team reviewed strategies for reducing the building energy use intensity, or EUI, at various thresholds as listed here. The reduced EUI levels target optimization in building envelope, airside systems, central plant systems, and future occupant usage and plug loads, while maintaining the current building massing and program. Based on the various EUI reduction targets, the team then reviewed the required quantities and potential locations for future on-site renewables. This information was used to estimate the probable cost of work relative to the overall project budget. The study anticipates a phased approach to implementation, which allows opportunity for enhancements where possible as future funding becomes available. Finally, the study also includes information regarding third-party sustainability verification for the new high school. While the study concludes that it is possible for the project to potentially pursue and achieve third-party verifications with some additional costs, ultimately the project team determined that the highest value proposition is in pursuing energy reduction strategies. The graph you see here shows the 5 options that the project team reviewed for energy management building configurations. This graph categorizes these options based on the energy use intensity, or again EUI, of the building and the site. The first option to the far left, labeled Energy Star Median Building, is a code minimum building with an EUI of approximately 70. While this is indicated as a code minimum building, it should be noted that advancements to the building code have created notable improvements to building energy efficiency when compared to buildings of just 20 years ago. Most new high school projects across the country meet EUI levels at or just below these improved code levels. The current high school design, which is labeled as the baseline schematic design building, is already a strong improvement on the code minimum building, achieving an estimated EUI of approximately 50. The middle column and the 2 columns to the right convey enhancements to the current schematic design through envelope, airside system, and central plant systems. To achieve these final 3 energy management building configurations, the project would incur some cost beyond what is provided in the current schematic design. The project team recognizes that there are several options available within the building industry for on-site renewables, including solar, wind, biomass, and hydropower. Many factors need to be considered when determining the most viable on-site renewable option, including the site's topography, tree line, the scale and density of the building program, noise generation, operation of the renewables, and the potential impact on nature and wildlife. Upon careful review, the team felt that photovoltaic solar panels were the most appropriate and viable renewable strategy for this project. The 2 diagrams here look at the potential locations for future photovoltaic systems to offset the energy use of the building. These diagrams are based on the current baseline schematic design of the building plus the enhanced envelope. We looked at both building-mounted and ground-mounted locations for the renewable system. Typically, with a multi-story building containing dense programs such as a high school, it's challenging to accommodate all photovoltaic solar panels on the roof. These types of buildings can usually accommodate around 40 to 60% of the photovoltaic systems, so the renewables we knew would need to be accommodated on the site. We did an exercise to assess where on the site we could potentially have future ground-mounted photovoltaic systems. We looked at locations within the parking area and adjacent to the performance field for potential future ground-mounted photovoltaics. Ultimately, our goal is to design a building that provides options for years to come. Pursuing a net zero energy ready approach will achieve just that. With building code improvements and improvements to industry building materials, the current schematic design, with its holistic approach to sustainability, will provide a healthy, enhanced learning environment for all the students.